about some electrical wiring basics that you might come across in facilities maintenance. Here, this graphic shows single conductors, wide different type of wires. You got stranded wire, solid core wire. Then you got multi-conductor cables, which means you got multiple wires inside of the cable. Romex is a commonly known type of cable that you'll see for branch circuits, lighting circuits. Generally, 14.3 is going to be for lighting circuits, where 12.2 you'll see on branch circuits. Large appliance cable is going to be a heavier gauge. And you also see BX, or type MC armored cable, for interior circuits only. This table 310.16 from the NEC, shows the different size American wire gauge on the far left and the temperature rating across the top. And of course you have copper, and then on the right hand side of the screen you see aluminum or copper clad aluminum. So 14 gauge wire is again used generally for lighting circuits controlled by a 15 amp breaker. 12 gauge wire is used for branch circuits, 120 volt receptacles for example, controlled by a 20 amp breaker. The heavier gauge wire, like 10 gauge wire, is used for like 240 volt branch circuits controlled by a 30 amp 2-pole breaker. And even heavier gauge wire, like 8 gauge wire and 6 gauge wire, would be used for like 240 volt branch circuits. 8 gauge wire would be controlled by a 40 amp 2-pole breaker. 6 gauge wire would be controlled by a 55 amp 2-pole breaker. So it's important to note, you need to know how many amps are going to be drawn when you're pulling wire for a new circuit, or even if you're buying an extension cord, you want to know how many amps that equipment draws, so you can buy the proper wire gauge, because you don't want to undersize it. The wire will get hot. That's a fire hazard. So always keep that in mind. Then different types of wires, THHN, THWN. Just as an example, there's many different types. And you can see what those letters represent. And the picture shows a length of stranded wire. This graphic here shows a different NEMA plug and receptacle configurations. So you see the red box around the 125 volts on the upper left corner there in the chart. So those are what you're commonly going to see like on a 120 volt circuit for receptacles and plugs. But you notice the different configurations correspond to how many amps that circuit is capable of handling. That's why there's different configurations, because they represent different ampacity ratings. So just something to keep in mind. Yeah, sorry if this graphic is slightly blurry, but basically it shows if you need to replace a cord cap on an extension cord or an appliance cord, you can buy those at Lowe's or Home Depot, Ace Hardware. Cord caps, you can buy female cord caps, male cord caps, and basically if you have a bad plug on your cord, you can cut it off and attach one of these replacement connectors. But always remember that we're talking about 120 volt circuits. The neutral terminal is the silver screw. The hot terminal is going to be your brass screw. And then you'll have your green ground terminal screw for your ground wire. So your black hot wire goes to the brass colored terminal. Your white wire goes to the silver color screw. And then of course the last one would be your green ground wire goes to that green terminal screw. Another thing to keep in mind on traditional 120 volt outlets and cords, the smaller slot and the smaller terminal is always going to be the hot. So just for proper wiring, keep that in mind. You don't ever want to mix up your hot and neutrals. That's it for today. I appreciate you watching. Please like, share, and subscribe. Let me know if there's any other topics you'd like me to discuss in a further video. I'll do my best to get those out there for you.